Hello everyone, let's try to solve some Leetcode today. So today we have this Leetcode 26 that is remove duplicate elements from the sorted array. Now this question is really easy if you try to use extra space, and that's why this question actually does not allow you to use extra space. It explicitly tells you to actually do all the operation in place, which means you're not supposed to use any extra space, whether it's array or set or anything else. And that's what makes this question kind of tricky for beginners, because what this question is really testing is your ability to make the best use of whatever space you have been given as an input. Because a lot of the times in smaller systems like embedded systems, you might not actually have a lot of space, right? Because it's not something like a big computer where you have GBs and terabytes of space. So that's what this question is trying to test a little bit in you. It is not trying to test your logic building. What it is really trying to test is your ability to use whatever you have been given. So what this question is telling you is that you will always have a sorted array. So sorted means you can always think of binary search or two pointers. So you will always have a sorted array nums, and will be sorted in ascending order, or basically non-decreasing order. What we have to do is we have to remove the duplicates in place such that each unique element appear only once. Okay, fine. The relative order of the elements should be kept the same. So it means that after removing the duplicates, the order of the elements of unique elements should be same. It means that those elements should also be in the ascending order, just like before. So after reading the question till here, we are getting a sense that we might need to do some operation on the array or on the given nums array, and then we have to return the array itself after the operation, right? Because that's what this question is saying, such that each unique element appear only once. So we are thinking that okay, we might need to remove the duplicates from the array itself completely, right? Till here we are getting a sense that we might need to return the array. Okay, let's go ahead. Consider the number of unique element in nums to be k. Now first of all, here are some discrepancies. First of all, what does the unique element means? Does an element which actually have duplicate is not unique, and only the element that does not have duplicates and only appear once in the array is unique? Like what is the unique element mean? What does this actually mean, right? And then we saying that unique elements will be some amount k. They have not specified what is this k, but there will be some k. They are not giving it in the input to us. Okay. Now after removing the duplicates, return the number of unique elements k. Okay, fine. So here we are seeing that okay, once we remove all the duplicates, whatever is remaining in the array will be unique elements, and then we have to give the count of those unique elements back. Correct? So here you actually get to see that okay, it is not the array that we have to return, it is actually the number of unique elements that we will get after removing all the duplicate elements from the array that we truly have to return. So k is what we actually have to return. K is the answer. Okay, fine. The first key element of the num should contain the unique elements or unique numbers in sorted order. That's fine. We already discussed that. The remaining elements or whatever else is in the array after the first key elements, that doesn't matter. That is none of our concern. Fine. So now we have to figure out what is this unique element is, right? So for that, what we can do is we can go to the example or the given inputs and output examples. So here we are seeing that, okay, we have been given an array nums, and the nums will actually have 1, 1 and 2. So 1 is actually repeated 2 times, and then 2 is a single element. So in the output, what we are saying is that 1 and 2 both are unique elements. So for 1, you actually have to remove all of its duplicates. So I removed this one, and then only this one remains, right? After removing duplicates, this one will remain and this 2 will remain. So these two by themselves are unique elements. So the number of unique elements after removal of all the duplicate elements is simple, 2, right? The number of elements are 2, 1 and 2. So this is how you use the test cases to actually verify whatever you are thinking or whatever you have assumed out of the question. And as you can see that underscore is here. So what this is representing is that after the first k elements that are unique, after the first unique elements, whatever is in the array, we don't care. It's none of our concern. That's basically what it means. And the same goes for this element. So we have 0, 1, 2, 3, and 4. And that's exactly what we have in the nums. 0, 1, 2, 3, and 4. So from 0 to 4, we have unique elements, right? And after removing the duplicates. And so whatever is the remaining space, we don't care about that. And we will have remaining space because we are not actually using a new array. We are only trying to use the given nums array, we are trying to make operations. So what we will be doing is we will basically take this element and bubble it up or shift it to the first few elements, then take two, shift it to the left again until we actually get something like this. And then there will be some elements in these array. Okay, there will be some elements in this position, but we are not caring about it. We don't care about what kind of order that particular space maintains after removing duplicates. So we are just saying that okay, this is underscore. It means we don't care. We are not worried about what or how things will look in this part of the array in the nums after all the operations. Now on looking at the constraints here, we can see that the length of the nums will be at max 3 into 10 to the power 4. Now, based on this constraint, we can actually eliminate a lot of the possible solution. For example, all the solutions that have time complexities of order of n cube and above will be removed. We cannot actually use those as a solution. Because if you just square it, or because if you just cube this number 10 to the power 4, it will become 10 to the power 12, right? And we can only perform around 10 to the power 8 operation in one single second, and so 10 to the power 12 is definitely greater than this. So we will get a time limit exceeded error. And so the best we can do, or basically the brute force that we can actually choose, is 10 to the power 8, or basically n square. So any solution that you can come up with that have an n square time complexity or less time complexity can be accepted here. But yes, n square is not optimal. Order of n or log n or n log n will be more optimal. You will have to see what kind of time complexity solution will be applicable in this question, and then you can apply that. So how do we solve this question, right? Well, one way is to, of course, create a set. We will have a set, and set always contain unique elements. Even if you pass 0 and then 0, the set will only contain one single occurrence of 0. It will not contain two zeros. Okay, so no matter how many times you pass a single element, it will only contain a single element and not the duplicate of it. So what you can do is you can just go ahead and put a pointer here p, then you add this to the set, then p will come here, then you again add this to the set, then p will come here, and then you will again add this one to the set, then this one, then this one. In the way, you will add all the elements in this set, right? And since set cannot contain duplicate elements, so it will only store one single occurrence or one single instance of these numbers. So the set will only contain how many? 0, 1, 2, 3, and 4. So what you can do is you can simply say return length of this particular set, and that will be the k, the number of unique elements that are that we have to return. So k is simply this number of unique elements, right? But this is unoptimal because what this is using till now is order of n time complexity, which is okay. Time complexity is optimal, but here we are using space as order of n. We are using an extra space for a set. Now, why am I saying order of n? Because it is possible that we might not get any duplicates in the input. We might get something like 0, 1, 2, 3, 4, 5, 6, 7, this type of input. So here all of it is basically unique. There are no duplicates. So we will end up putting everything in the set, and then we will just count the number of elements in the set. So that's why I'm saying that the space is order of n at the worst case. Now, how do we make this solution optimal? How do we make sure that we are using order of one space and not order of n space? Well, we can only do this by using the given space and make our operation on this space somehow. Correct? So let's just take another, basically take the same example. Let's not take another example. So what we can do here is that we can first of all try to figure out what kind of algorithms or what kind of patterns we can apply on it. Since this is basically a sorted data, so what I can think of are two pointers, then greedy solutions, then some kind of sliding window, some kind of trick kind of thing. So something that will work in order of n. So at this point, I can think of two pointers and binary search. Okay, so both of these work on sorted data, but this kind of problem cannot be solved via binary search because we have to go through the entire array and we have to process each and every element. Because we are not supposed to find some particular element. That's not what we are supposed to do. We are supposed to go through the entire array and make some operations and then basically return the number of elements that are unique. So binary search kind of goes out of the question. The thing that remains is two pointer. So let's try to use the two pointer in this case. So let's make a few variables, that is a is equals to 0, b is equals to 1, and I will tell you why, and then k is equals to 1. Okay. So in case, okay, in case you have an array with a single element, right? Suppose that you only had this much array. So that single element will itself be a unique element, right? So the k will anyway start from 1 always, because there will always be a one particular unique element in the array, right? So, and that will only be false. Okay, this will only be false if the array is empty. So that will be an edge case. If the array is empty, you simply return 0. That's the edge case. That is the kind of an edge case that you have to think of. But we can always start the k from 1 for any further processing. Now we have the array pointer a here, and then we have b here. Okay. Now we will first of all try to check, does the element at b equals to the element at b minus 1? Well, these are currently equal. So what I will do is I will simply move b to the next element. Now I will again check, does this element equals to the b minus 1 element? And currently they are not equal. So what does this represent? Well, if you really look at it, this will only happen when we have actually somehow crossed this particular boundary. We had a few duplicate elements of a particular type. Okay, since it is a sorted element, so all the duplicates will be in the same place. So we have basically a range of duplicate elements, and once the b is not equal to b minus 1, what we are thinking is that we have crossed that range and we have entered a new range of duplicate elements, correct? So basically what we are saying is that we have found another element, that is 1. We have found the another element, and so this is what we have to track. Okay, so we have to make sure that we put this 1 somewhere in the starting of the array. So we have 0 already in the starting of the array, and 0 itself is a unique element, so we can only put 1 after 0. And at this position we have a. So what we will do is we will say nums of a plus 1 is equals to nums of current b. So this 1 will actually go to here. So this 0 will become 1. Getting it? This 0 will become now 1. So this is gone and it's 1. Now what we will do is we will actually shift a to the next pointer. So a will now come here. B will now again come here, the next one. And k will become 2. Because now we are at the position of, so 0 position, 1 position. So k will become k plus 1 is equals to 2. Correct? Simple as that. Getting it? Now what we can do is we can actually go further. So here the b is now at this position. Now we check, does this equals to this previous one? So yes, these two are equal. So what we say that, okay, just increment the b to the next one. And again, these two are same, b and b minus 1 are same. So we will again increment to the next one. So b is now here and we get 2. So at this point, this and this are not equal. So what we are saying is that we have again reached some kind of boundary. Okay, so we have reached a boundary and we have found a new element, right? So what we are supposed to do is we are supposed to take this element and we have to basically put it in the earlier place in the array, right? So basically we have 0 here at this point, then we have 1 here, and so the only place where we can actually put this 2 is this one, correct? So what we will do again is we will say a is equals to, or not a actually, nums of a plus 1 is equals to nums of b, and that will become 2. So this one will become 2. So as you can see that we are now bubbling, or we are basically accumulating or shifting all the unique elements to the first part of the array in the nums itself, correct? And again we will just shift the a to this position, the b will be shifted to this position, the k will actually become k plus 1 is equals to 2 plus 1 is equals to 3, correct? So we have 3 unique elements till now, till here, correct? And in the same way, we can actually go through the entire list. So the B is here too. And these two are still equal. So we will not do anything. We will simply increment the B pointer only. So B will come here now. We have again reached a boundary condition. We can see that these are not equal, correct? So we will take this 3 and we will again say that this position, A plus 1 position will now become 3. So we will say this is now 3. Okay. And now we will simply shift a position pointer to here. The b will be shifted. So b is here. So b will be shifted here. And the k will again be incremented by 1. So k will become 4. Correct? And now, as you can see that b is here currently, right? So these two are equal. So we will continue. So b will only shift. B is now at 4. We can see that these two are not equal. So it means that we have found a new element basically. So we will actually take this 4 and we will put it again on a plus 1. So at this position. So 4 will come here, a will shift here, b will shift here. So b is now out of range, correct? And k will also increment. So k will become 5, correct? So now at this point, b is more than length of the array. So b is more than length of the array, correct? So what we can say is that we can now stop the loop, correct? So all the things in the nums array from 0 till wherever we have a. So currently the a is at position 4. Now position 4, okay? So array is a 0 based data structure, right? So the positioning starts from 0, 0, 1, 2, 3 and 4. Since a is at 4th position, what we are saying is that we have 5 elements including 0. So you can directly calculate k from here also. K is equals to a plus 1 or basically 5 elements, right? But we have already calculated k, so we can directly return from here. Now you didn't actually have to go through all this stuff, okay? Like there is another easier way to kind of do this. Now if you really look at the question, you are not supposed to return the array. Getting it? You are not supposed to return the array, you are just supposed to return the number of elements, unique elements k. So why did I go through all this trouble, right? This I went through this trouble just to make sure that even if you are asked to return all the unique elements, you will be able to do this. Okay, you will have the access of all the unique elements. Look, this problem will become even easier if you just have to find out the elements, number of elements. The above issues or the above headache we actually took because we wanted to find all the elements themselves, right? We wanted, if we wanted to actually kind of return this particular element array, and if the interviewer asks you to give me all the element array till here, till A, you will be able to do this with the help of this particular solution. But if all you need to just get is the number of elements, what you can do is you can actually keep a pointer here. Okay, simple. We will have a B here, and then we will keep incrementing. Okay, and once, okay, so K will start with 1 here. Okay, as we find these boundaries. Okay, so whenever B, nums of B is not equals to nums of b minus 1, what we can directly say is that k is equals to k plus 1 and b is equals to b plus 1. Simple, right? Because in this case, all we will do is we found the boundary, we will increment the k because we know that we found a new element, correct? Again, we found a boundary, we know that we found a new element, so we will simply increase the k. Again, we found a new boundary here, so we will increment the k, right? Again, we found a new boundary, so we will simply increment the k. Now, at this point, we do have the k. We have the answer directly 5, but we don't know what elements were unique at this point, right? In this solution, we actually knew what elements were unique because we actually found them with the help of 2 pointers. But in the below solution, yes, you do get the k, so it will be actually accepted. But in case if you are asked to tell what are the unique elements, list them out, you will not be able to do that here because all you did is you just incremented the k based on the boundaries, right? You did not actually keep track of the elements, the unique elements anywhere, so you will not be able to do that. Now here's the Python code for this. We are basically doing the same here. We are instantiating with a is equals to 0, b is equals to 1, k is equals to 1. And then what we are doing is that if okay, so while b is less than length of the nums array, correct? So if b is equals to b minus 1, we simply just continue, right? We increment the p pointer to the next element and we continue. But in case if it's not equals, we know that we have hit a boundary and we will simply say nums of a plus 1 is equals to nums of b. We will increase the a, we will increase the k, we will increase the b, right? And at the end of the day, we will simply return k and that will be our answer. Simple as that. Now let's run it. And you can see that we have some unrealistic number here that is 100% takes 0 millisecond. Yeah, I mean, you cannot really trust it all that much, but yeah, that's basically how it works. So memory is also very efficient. It beats 74%. So memory, we have been able to just do it in order of one page complexity. So yeah, that's pretty efficient. And yeah, so if you have some kind of DSA question that you would like me to target, then just let me know in the comments. Bye.